There is a state transition dependency graph because I wanted to make it clear that parts of the state transition can be parallelized and pipelined and so forth. So for example, the posterior time is only dependent on the header, right? It doesn't depend on any other part of state. It doesn't even depend on the prior version of time. It's just like you literally just take the time that has been oracleized in the header says it is, and you stick that in your time state. Some things have these, some of the state items have things like daggers after them, right? This is an intermediate state, yeah? So we cannot, the dependency graph we don't immediately go sort of to the posterior state. We kind of go through a few stages, and maybe one of these stages is used in the determination of some other part of state. I mean, that's generally what this intermediate state is. So for example, recent blocks beta, we actually first named this intermediate state beta dagger, and we use the header and the prior beta to work out beta dagger, and then beta prime, so the posterior beta, we use beta dagger for that, but we also combine a couple of other things, including the report guarantee portion of the extrinsic. Capital bold E, subscript capital G. And we also use this C thing. This is a bit of data that we calculate later on in the block, but that we actually calculate it during the accumulation phase. It's just sort of an anonymous variable. Using this, you should get an overview as to how various bits could be parallelized during block production, block execution. Good. As it points out, in fact, most of it is parallelizable. There's only a few bits that are sort of what I've called synchronous entanglements. Most of the state can be sort of worked out independently of the other components, but there are a couple synchronous entanglements which are basically identified by the parts that don't just take an extrinsic and a prior state and give the posterior state. So this is an example where it's totally independent. You can calculate the posterior state of this validator slashing part of state just by looking at the previous version and an extrinsic, or portion of the extrinsic. Similarly, for example, eta prime can be calculated purely from looking at the prior version of eta, the time, and the header. Yeah. Okay, let's look into actually how to calculate these things. This part just basically talks about SAF roll, which we already know about. This part talks about time, which we already know about.